This is Richard Turnock with Systems Academy again. The first video that you should have watched before this one was called One-Dimensional Motion with displacement, velocity, and time. This is a second video in that series. This one includes acceleration. So if you remember in the prior video we had the model that's shown here at the top, the flow and level. The velocity is has a direction and it causes a displacement. The initial value of the displacement is 10. Speed is the scalar value, and those are all based on the Khan Academy's equations. You see those on the left here on the screen. Then we've added to this model another level called velocity, and the flow is called accelerating. So we always use a noun as the name of a level, and a verb is the name of a flow. Usually. So in this case we have accelerating, and we have an acceleration rate is the rate at which the whatever it is that we're going to move. It could be gravity, if gravity's acceleration rate of acceleration could be something being dropped, or we could be talking about something being moved, like a car or a train or something. And here I've started with the initial value of 5 for the velocity, connected that to the speed so that the speed is still 5 as in our last video. And here you can see that we get the same results. So this has the same linear result as the prior video with these values. So you can see we haven't changed anything. This is where the acceleration rate is 0. We would expect a linear value. So let's go in and change the acceleration rate, and let's give it a value of 1 in our first attempt here. And then we'll run the graph again. And nothing changed. Why? Because I didn't change the equation here for accelerating. I need to change the equation here to use the acceleration rate. All right, we've got that now. Now let's try it again. Okay, there we go. So now we see the stretch this out here. That looks different, doesn't it? So here we see the blue line is the growing velocity. Each unit of time it goes up by 1, but the displacement is not linear. That's because the velocity is continuing to increase. In our first example, we had a constant velocity of 5, but now that's the initial value of 5, and then each time period it goes up by 1. As the velocity increases, the displacement is going to become an exponential curve. It's going to accelerate. It's going to go even faster, the displacement. So we get this curve. And we see that in the same time period of 20 with acceleration, we go probably three times as far with acceleration of 1 as we did with just a constant velocity of 5. So your assignment would be to use this model and put different values of the acceleration rate and different initial values and get different graphs and maybe change the time settings to look at a longer period of time. Let me give you an example of how to do that. You need to use a small number here in the simulation time step. You can use 0.125, but you could increase this to, say, 50 and minutes, and then use this accurate value and then apply those time settings. And let's see what we get this time. We'll run the graph. And I must have, oh, I didn't put a decimal point in there. Oops. 0.1. 0.125. There, that'll work. Okay. So now we get a graph. It looks better. And here we get a nice exponential. Wow, look at the values going up. So that's because we went out to 50. You look back here at 20 and we're still back here at 300. It's about 300 after 20 minutes. But by the time we get to 50, we're a lot farther away. You see that acceleration changes the displacement over time in a rapidly increasing rate. Okay, so that would be your next assignment. Your homework is to build this model and play with it to understand acceleration.